Hello everyone. So I'm going to show you how to create this complex sinusoidal form. So it will also be able to twist like this. Alright, so I'm going to show you how to make this on Dynamo and also Grasshopper. So I'm doing this as a way of learning Grasshopper. So this will be useful for Dynamo users and Grasshopper users. So you can, if you're a Dynamo user and trying to learn Grasshopper, it's obviously cool to be able to replicate something in another software. This will also show you that the concepts, of creating something in Dynamo is pretty much similar to creating in Grasshopper, but the nodes are just named differently usually. So that's the only thing. But if you're a Dynamo user, you're pretty good at Dynamo. I found it to be relatively easy to pick up the next computational design software, because they are the thinking behind everything we do is pretty similar. All right, so yeah, let's get into the tutorial. Okay, so this workflow was inspired by this building, the Bahai Temple in Congo, designed by Wolf Architects. Yeah, so this was a building I worked on while I was there, and yeah, we were trying to create this flowy skirt at the base there. It wasn't made in Dynamo at the time, but I just decided to try to make this form using some Sine math in Dynamo, and yeah, so that's what we're going to be doing. Yeah, so have a read about the building. Yeah, so some other images, so you can see that wave over there. So that's kind of the effect I'm trying to go for. But the one we're going to be creating will also have a twist to it, as you could see in the videos. And you can see these the tiling patterns. We automated that using Dynamo, so you can actually take a look at this right up here. I wrote on the Dynamo blog. Basically shows you what steps were taken to automate the tiling process and creating the drawings on Revit. All right, so let's get into the tutorial now. So the graph of the Dynamo workflow is basically broken up into the inputs, and over here is we're going to be creating the circles, base circles, and then we will convert those circles into sine waves, and then we will split the surface that's created by lofting those waves that were created using a Nobs curve, and then we will rotate the split surfaces. All right, let's get into it. Okay, so let's start. So the first thing we have to do is get a point dot by coordinates. Okay. All right. Then we need 3 inputs for this node. So to get the 3 inputs, I'm just going to right click on the canvas. So this is another way you can get nodes for those people, for new Dynamo users. You can either go over here or just right click over here on the canvas, and I'm just going to type in number slider. Okay, so within the number slider, I'm going to click this button over here, this drop down, and then over here I can see the minimum and the maximum and a step. So the minimum, I'm going to have a 0. I'm actually just going to leave it like this, but the step I want to be 1. So the step affects the increments of the numbers. So if you have a step of 0.1, the numbers are going to change by 0.1, as you can see now, 12, 13, 30.7, you see, and so on. So but I want the increments to be in 1, so I'm going to leave it as 1. All right. Okay, so I'm just going to copy this 3 times so we can change the x, y, and z coordinate values. So Control C, Control V, Control V. All right. Then I'm going to rename this one by double clicking on my left mouse button as X, as Y, and then as Z. Okay, so now I'm going to plug these in here. So X to X, Y to Y, and Z to Z. All right, so as you can see now, there's a point over there, and then I can chain the X and it moves along the X axis, the Y along the Y axis, and the Z along the Z axis. So if you're not seeing that effect on your screen, it's because your run is probably set to manual, right? So when you change an input, you'll have to hit run. But if I change it to automatic, whenever I change something, it changes automatically. So you want to change it over there as well. Okay, so now we've created our first node. It creates a point. So I like to group my inputs together, as you could see in the graph, the previous graph I showed you. So then I'm going to remove that, and I'm just going to double click here and say inputs. And then I'll right click on the color to make it a gray color. Yeah, so that's how I like to color code my inputs. So the next thing we need to do here is use a code block to create a range of numbers that will allow us to create circles that are hosted to that point. All right, so double click with your left mouse button on the canvas and then type inner dot dot outer dot dot hash divisions. So you can rename yours however you want. So what I've done here is I'm making variables inner and another variable outer and another variable divisions. So what a variable does, it allows you to assign different numbers to those letters. So the letters, to the words, they are called the variables, and I can assign number sliders and other input types to them, and they can retain those values. So, but you'll see what I mean now. All right, so let us create, let's copy this number slider. Okay, and then Control C, Control V, and then what this is here is inner. So this is basically going to be the inner radius, this is the outer radius, and this is going to be the divisions between the circles between. It's going to be creating the divisions. All right, so what I'm going to do here is I'm going to double click with my left mouse button and say inner radius, right? But I don't want the radius to be less than, let's say, 5, or else the circle is going to collapse if it's less than 1. So I'm just going to make a minimum of 5 there, and the maximum 100. That's fine. I'm going to copy this again, Control C, Control V. Now say outer radius, all right, so the inner and the outer radius never clash with each other. I'm going to make the minimum here about, say, 55, and the maximum, let's say, 200. All right, so that so the minimum there is 100. So let me actually make this 105. There we go. All right, so let's plug inner to inner here, and then outer radius to outer, and divisions. I'm going to make something called an integer slider. Right click on the canvas and then search for integer slider. Sorry, it seems to be okay, I'm gonna try that again. It was a bit of a bug. Integer slider. Okay, there we go. All right, and let's say the minimum divisions will be 2, maximum 20. Right, so the integer slider will not let you have decimal numbers because they have to be whole numbers, and integer is a whole number. So I'm just going to have the step as 1 as well, and then I'm going to rename this as radial divisions. All right, then we can plug divisions in here as well. Okay. So, but briefly, let me explain what this means. Okay, so I'm going to create another code block. and I'll say here 0 dot dot 5 dot dot 1. Okay, so what this is basically then doing, it's creating about, let's see, 6 numbers from 0 to 5 with a step of 1. So the step means that it is going to add 1 from the beginning, right, till it gets to 5. So 0 plus 1 is what? 1. 1 plus 1 is what? 2. So if I change the step to 2 over here, it's now going to add 2 to 0, and you get 2, and then it's going to add 2 to 2, and you get 4. Okay, so, but because when you add 2 to 4, it's going to give us 6, it's not going to show you that last number. Okay, so, but what if we make it hash, and we say 10? Okay, so what it's doing now is dividing it's dividing the range from 0 to 5, right, into 10 equal parts. So it's giving us 10 numbers from 0 to 5. So then we get 0, 0 0.5555, 1.1, and the other numbers up to 5, right? So but as you know, a list always starts from 0 and to 9, so there are obviously 10 numbers here. So that's what we're basically doing, but instead of putting an actual constant, which will be 0, and another constant, which is 5, a constant is basically something that wouldn't change, it's fixed. We're making a variable which makes those numbers, which allows those numbers to vary. So if we're trying to create a lot of circles, we don't want it to be, we're trying to allow for flexibility when we're changing the shape, that wavy shape. We don't want those base circles to be fixed, right? We want to be able to change them. That's why we apply variables. I hope that makes some sense. All right, so the next thing we now need to do is to add a node called circle by center point radius. So just right click on the canvas, type in circle dot by, oh sorry, spelled circle incorrectly, circle, okay, you can see it, it's the first node there, by center point radius. The center point is point over here, right? You plug it into a center point, and then the radius, we have a list of numbers over here, but we can add more. Let's say we want it to be what, 15. We want to create 15 circles, so we're just going to plug this over there. So as you can see now, we have a few circles on our screen, and we can go back here and play with the numbers and play with the parameters. You can see that, and then the outer radius, we can play with that as well, and we can also play with the divisions. So it's always good to flex your script to make sure no errors occur. As you can see here, everything works pretty well. All right, so let me just group these. Okay, and so now I've grouped them, and I'm going to group this as well. Control G, backspace, and I'm going to say create the circles. All right, so let's go on to the next step. So the next thing we have to do is convert these circles that we've created into sine waves, right, with a vertical sine waves that are flowing in the z direction, that's vertically. So yeah, so so each of these will get a sine wave assigned to it. Okay, so let's go ahead. So the first thing to do is add points on each of these circles, right? Let me just reduce the amount of circles so it doesn't get too intense. Okay, so I'm going to look for a node called curve dot point at parameter. There we go. All right, so what it needs, the first input that's required is curve, and these circles, yeah, all 10 of them are curves, right? So we plug them in, right? And by default, the parameter that's assigned, if you look here, is 0. So it means the point is starting at the first, the points are going to be placed at the beginning of the curves, right? Even a circle has a beginning and an end, right? So that's why it's placing it over there. That's the beginning of the circles. All right, so for less experienced Dynamo users, you just need to know that every curve starts with a 0 and ends with a 1, right? So whenever you place a parameter of 0, it means the point is going to be placed at the beginning of the curve. All right, hope that's clear enough. So what we need to do here now is add a new kind of parameter here, because we want to be able to create a sine wave that moves accurately along the circle's circumference. And if we only have one point to move, right? If we only have one point to create the sine wave, that's not going to work. We need a lot more points along the circumference of each of these circles. So what we're going to do is we're going to use a code block to create a range from 0 to 1. So what I'm going to do here is say, just double click with my left mouse button and then say 0.1 ... hash divisions. Okay, so what I've done here is create a variable, right? And I need to assign the divisions to that. So what I'm going to do is I'm going to duplicate this node over here, Control C, Control V. And I'm just going to say something like, say circumference divisions. Circumference, yeah, that is fine. So let me just see how many. Okay, so let's make the maximum 100. Let's say minimum is 2. That's okay. And I'm just going to add it to the group. Okay, and I'm going to plug that in over there. All right, and then I'll plug this in to here. But as you can see, what happens here is that instead of the points being placed, instead of 10 points, right, being placed along the circumference of the circle, it places 1 point along each circle, right? And that's obviously not what we want. We want each circle to have 10 points. Okay, so what I'm going to then do here is do something called cross product. You need to right click on this node, right, and then look for lacing and then cross product. So what cross product means is that apply this to each item on the list. So each item here, each circle, right, that's contained within this list, apply this apply this function, right, to each of them. So it means that if you're applying the function to each of the circles, it means it's going to create 10 on each circle, right? So now if I change this parameter over here, I'm going to have a lot more points on each circle. All right, so there we go. So that's the first step here. So the next thing we need to do is create the formula, the sine formula that's actually going to create the waves. So I'm going to double click with my left mouse button again to add a code block. So over here I'm then going to type math dot sine, then in brackets 0 ... 360 multiplied by cycles and ... hash divisions. Divisions. Okay, so let me just explain what this means, right? So the first so let me start from here, from the range. So first we're starting from 0 to 360. So a typical sine wave, the standard is, it's when it goes up and it comes down and it goes back up, that is a 360 revolution. So what we're doing is we're saying from 0 to 360, so that is one wave. Then we're multiplying that by cycles, which means we want to have, so if we had 7 cycles, we're going to have 7 sine waves, right? So that is our range, okay? And then we're dividing that by the number of points along each of the circles, right? Okay, so let's take a look. Let me just create another Control C, Control V, create another input here for the wave count. So let's just say wave number. I'm going to change this to, let's have it at 20. Let's see, 30. Okay, I'm going to plug that in here to cycles. Actually bring this down so it's neater. So what I can actually do is move this here so they don't tangle. Okay. You can actually just rename this as cycles so the variable name is the same. Okay, then after that, what I want here, oh sorry, that was a mistake. So this should actually be cycles. Okay, then the next thing here is to put in the visions over there. Okay, so now when we look over here, and for the other thing I forgot to mention is that you obviously have the sine here. If I take this off for now, let me just copy this, cut this out. Okay, and if we look at the list that's created, you can see it's creating numbers from 0 all the way to 360 multiplied by cycles. If I change the cycles just to, let's say, 2 cycles, right, it goes all the way from 0 to 720 because, right, 360 multiplied by 2 is 720, right? But with 7, it's going all the way to it's going all the way to 2520 because that is 360 multiplied by 7. And then from that range, from 0 to 2520, we have divisions, which are, right, 50. So we have 50 numbers from 0 to 2520. So that's what it is, like as I explained earlier. So it's pretty simple concept. And then when I plug in the math.sine, it basically converts those numbers, right, from 0, right, to -1. So it's basically creating the numbers to create waves, to create 7 waves, right? So it goes up, if you look at the numbers, right, goes up, it goes down a bit, then it comes up again, then it goes, and the numbers keep rising and falling. But you understand what I mean when I fully create the sine wave. All right, so then the next thing we need to do is map these very low numbers, because I'm sure you've noticed, this is not going to create any much height because they are very low decimal numbers. So we need to map these numbers to real world numbers to be able to create to be able to control the height of the waves. All right, so what I'm going to do here is then create 2 more inputs. I'll just right click and look for a number slider. Now just rename it, double click with my left mouse button and say wave height 1, and just the minimum you can leave at 0, maximum that's fine, and just change the step to 1. and I'll copy and paste this, and I'll say wave height 2. All right, so what we need now is a node called math.map2. Sorry, delete that. So right click and look for math.map2. Okay, so what we want to do is map these numbers here that are very low from the range of the wave height 1 to the end of wave height 2, right? Okay, so what I'm going to do here is take this wave height 1, plug it into the target range min, and then plug wave height 2 to target range max. And the input values are these values here. These are the values to be remapped, to be mapped, okay? And then the range minimum is, we want to get the minimum value in this list of numbers. So I'm going to look for a node called list.minimum item. Grab that and plug it in there, and then put it in here because that is the minimum item here. So you can see the minimum item in this list is minus 0.97. Okay, and then I'm going to look for another one called maximum item, list.maximum item. Okay, you grab the maximum item, you plug the list in there, and as you can see, it gets the largest item on the list, which is 0.97. And then I grab that item and I plug it into range max. So now when we check this list over here, you'll see that all the numbers in here have been remapped, but they're all at 1, 1, 1, 1, 1. Why is that? Because our inputs are also at 1 and 1. So if I change this here, let's say to 25, and I move this one to 71, you can see now it's mapping all the numbers along those numbers. I mean from 25 to 71. So you can see here it's 49, 66, 71, 58. As you can see, it's rising and then it falls again, creating that wave. But you'll understand as we actually use the numbers to move the points. Okay, so as you can see now, we've created these numbers we're going to actually use to move the points along the z-axis, and these ones we used, these numbers here we used to add the points along the circumference. So now let's actually use these numbers here to move the points vertically. Okay, so to do that, the node we need now is called geometry.translate. Sorry, delete that again. Right click and look for geometry.translate. And you want the one of direction distance. Okay, what geometry are we trying to translate? The points. Okay, the direction will be z along the z-axis. So you come in here, look for vector dot z-axis, which is that. So the z-axis means the points will move up vertically, right? If you wanted to make it more complex, you can use another vector that makes it move in another direction, which would actually make the shape more interesting as well. But let's keep it simple. Then we just plug this in to direction there, and distance, it is these numbers that we've mapped, right? The sine numbers that we're now grabbing and plugging into distance. And as you can see here, the numbers have the points have been moved. Okay, so but obviously doesn't make much sense at the moment. So what we're going to do is create a NURBS curve dot by control points, NURBS curve dot by control points. Okay, Just plug that in here. Oh, sorry, I think I actually need to take this, use levels. Okay, there we go. So I'll explain that as well. So as you can see now, we now have the waves over here. Okay, so the issue here is if you look at this list here, so you see there are 1, 2, and 3 levels, okay, which means this is level 1, okay. At the level 1 is at the item, each item in the list. Level 2 is an entire sublist, and level 3 is the full list of all the points, okay. So as you can see here, there are, you see 1, because there are 10, we have 10 circles, right? We will have 10 sublists. So 10 sublists with about 50 points, you see. So up to 49, which means we have 50. So you can see this is number 1 over here. Then if I go all the way down, we should have 9. So that means 10. So we have 10 lists with 50 points. So what this level 2 is saying over here is it's saying that we want to apply all these heights. You see, all these 50 heights, yeah, to each sublist at level 2. Okay, so if you don't apply it correctly, those waves will not be created. All right, so as you can see now, we have the wave created. So to appreciate it, I'm just going to hide the points. Okay, right click and remove preview geometry. And I'm also going to hide these circles we created previously. Okay, just by right clicking on the group, and actually hide this as well. Okay, and then I'm going to group these together. Control G, and then say create sine wave curves, full stop. And now when I play with it, and I change the parameters here, as you can see there, the heights change. Okay, you can, the circumference divisions adds more points to those lower circles, which makes the wave more accurate, right? As you can see. So the less points, the less accurate it is. So I'll probably take it up. And then the cycles means the number of waves you're creating. So as you can see here now, it has a lot more waves. Okay. And the radial divisions just means the number of lines between each, from the start wave to the end, as you can see there. Okay, so that is that for this, and I'm just going to group this together. And yes, and see you at the next part. So the next thing to do is to create surfaces between each of these NURBS curves. All right. So if we were to just loft at the moment and create the surface, if I go here to the search bar and search for surface dot by loft, as you can see, a surface is made, but it is just one surface, and that would be hard. That won't create the twist effect we had in the beginning. So to create that twist effect, you can see along these lines here, we need to create surfaces from and between each NURBS curve. So there has to be a surface here, a surface there, and a surface there, and a surface in between there, and so on, right? And that is what's going to allow us to create that effect that we saw in the beginning. But now in this list, all we have here is one surface. So to do that, we need to do some more scripting. All right, so let me just get this out of the way. All right, so the first thing you need is to look for a list, a node called list dot of repeated item. Okay, so what this node is basically doing, it's going to take this list of NURBS curves, yeah, and it's going to repeat it as many times as we want. But for this, for what we're trying to achieve here, we only want to repeat this list twice. So I'm just going to grab this list of NURBS curves, put it in the item input over there, and then double click with my left mouse button to release a code block and type in 2. Okay, so the amount of repetition of this list will now become 2. So let's take a look at what's in the list. As you can see here, there are 2 lists with 20 NURBS curves, because there are 20 NURBS curves in this list. So now we have 2 lists. If we change it to 3 over here, there will be 3 lists of 20 NURBS curves. Okay, but we don't need that for this, so we only need 2. Okay, so the next thing we have to do is to transpose. So there we go. Transpose. I'm going to grab this list and open this up. So what happens when you transpose? Let me use a watch node. So I'm just going to search for watch. Put it in there. And a watch node helps you view the items in a list much more clearly, because you can actually make it as big as you want. It's similar to the panel in Grasshopper. Okay, so you can see here we have 2 lists of 20 NURBS curves. So what transpose does, it pairs the first item in the first list and the first item in the second list, the second item in the first list and the second item in the second list, and so on. If you had 3 items, if you had 3 lists of 20 NURBS curves, it will pair the first item in each list, and so on and so forth. Okay, so that's what transpose does. And in Grasshopper, that node is called flip matrix, right? So for the Grasshopper watches. And so as you can see here, we now have 20 sublists containing 2 NURBS curves. All right, so let's continue. So the reason for that is, so at the moment, although you can't see it, there are now 2 NURBS curves sitting at each point there. So each NURBS curve that you see here is actually 2, right? So the next thing we're going to do is remove the first NURBS curve and the last NURBS curve, and then we'll pair, and we'll create pairings between the first and this one, and between this one and the next one, and this one and the next one. But let's continue, and it should be clearer as we go along. So the next thing to do, the next node we need here is list.flatten. Okay, so when you use a list.flatten, it essentially flattens the entire list. It gets rid of the sublists. You see here now it's a list of 40 NURBS curves, all flattened into one list. No more sublists, as you can see here. All right, so then after that we need to get a list.remove item at index. So we grab this list, and now it wants to know what indices we want to remove items at. So what we want to do is remove this first item and remove the last item. Okay, so the first item is at the beginning, as you can see here. So it's right here, and the last item would be over there. Okay, so what I now have to do to remove the last item, I need a list.count. So list.count tells us how many items are in this list, and obviously it's 40, so it's giving us 40. And then now I want to supply the indices input into this list.remove item at index. So what I have to do there is bring up a code block, double click with your left mouse button, okay, then type in a list. So to make a list in a code block, you have to use the square brackets, and I'm going to type in here 0, count minus 1. So the first index I want an item to be removed at is 0, so it means it will take out this one. And the next index is count minus 1. Because the list starts at 0 and the last index is 39, we're basically going to remove 1 from this 40 to get that 39. So then I'm going to plug this count in here. And when we open this list up that's created, we have an index of 0 and index of 39. So which means the last item, which is at 39, and this first item at 0 will be removed by this node. Okay, I hope that was clear. And you grab that in there. And as you can see now, we have 38 items, which means 2 items have been removed from this list. So now we don't have, we've removed that first item and the last item. Okay, so now we have a new list with 38 items. Okay, now the next node we need to add here to pair that item and this item and that item. So let's just take a look visually here. Okay, so let's move here. So as you can see here, when I pair this one and this one, it will create, and I loft between them, it will create a surface between those two. This one and that one, it will create a surface between those two as well. And this one and that one. So that's what we're trying to do. So but let's continue. So let's use a list.chop. Okay. So list.chop essentially divides a list by the lengths you want. So chop a list into a set of consecutive sublists within the specified lengths. So the length we're trying to divide by here is 2, because we want a pair of NURBS curves. And then now when we look into the list here, we have, as you can see, 2 NURBS curves in each sublist, right? And yeah, so that's that for this step. Then the last thing we need to do is actually loft. So let's look for surface.byLoft. .byLoft, that one. And plug that in there. And then when you look into this list here, as you can see now, we have multiple surfaces compared to in the beginning when we just had one surface. Now we have several surfaces here. Okay, see, 3, 4 that are moving between each of these NURBS curves. You see. All right, so what I'm going to do now is just group this together. Control G, backspace. I'm going to say create split surfaces. So it's always a good idea to group parts of your workflow together, just for easy debugging in future. Yeah, you'll thank yourself in future for doing that. Very useful. All right, see you at the next step. Hello. Just so you can see the split surface much more clearly, let's actually give them some colors. All right, to do that, we're going to look for a color palette node. Let's type in the search bar, color palette. Okay, we're going to copy these 3 times. Control C, Control V, Control V. So I want to create a range of colors that uses 3 of these colors. You can limit yours to 2 if you want. So I'm just going to pick a red and say apply. Pick a blue, apply, and pick a green. You can look for nicer colors for yours. All right, then I'm going to use a code block to group these into lists. All right, you can use a list.create for that as well. List.create. Okay, and then push this button 3 times and it creates a list like that of the 3 colors. Okay, so that works. But I'm a big fan of the code block, and I would just do a square brackets and type in red and blue and green. It's like that, and then I put those items in that list, and it does the exact same thing, right? But let's stick with the node. Okay, so from there we need a color range node. Range, and we plug those colors into the colors input, and now it's asking us for indices. So what this means is it wants to understand at what positions to place the colors you've inputted. So I want the red to be at 0, and 0 is here. I want the blue to be in the middle, which is 0.5, and the green to be at 1. So the range goes from 0 to 1. All right, so what I'm going to use is a code block. Double click with my left mouse button, open the square brackets to create a list, and type in 0, 0.5, 1. Okay, and then I plug that into indices. Okay, and then the value the value is basically asking, because we want to color all those 20 split surfaces we've created, it wants to know what color values to pick for each of them. Okay, and to create that value, I'm sure you've guessed it already, we need to create a range. Okay, so what we're going to do is look for a list.count again. Right, and grab the list of surfaces, and gives us a count of 19. So we've got 19 NURB surfaces. Okay, and then from there we create a range. So I'm going to use my code block again and type in 0.1 hash count. Okay, so because this range is obviously from 0 to 1, we want to stick within that range. That's why we're using a list of numbers. We're creating a list of numbers from 0 to 1. Okay, and then it then gives us 0 all the way to 1, and you can see these very strange numbers over there as well. And just so the numbers, the colors are not picked in an orderly fashion from 0 to 1, which would kind of make a gradient along the surfaces, and I want a distinction between them. So what we have to do is shuffle these numbers so the colors are picked in an orderly fashion. Okay, so let's look for list.shuffle. Okay, so when you shuffle the list there, as you can see now, the numbers are not ordered. Okay, so which means it's not going to be picking the colors in an orderly fashion. Okay, so now we've picked up the colors, so a list of 19 colors that will now be applied to these surfaces. So the last node we need for this is the geometry color. Okay, by geometry color. Okay, so the geometry we're trying to color is what? The surfaces. So I'm just going to plug that in over here, and the colors are these colors over here. So but to see the colors, we actually need to hide the initial surfaces, and then now we have our colors, as you can see. So now you can clearly see that there are surfaces between each of those NURBS curves. All right, so it's going to give us the effect that we are looking for when we twist them. We rotate them around the center point. So if you're not happy with how this looks, you can obviously come here and pick a different kind of red, or even choose a different color altogether, like the green. Let's use, no, it's meant to be a blue. Yeah, you get the idea. Great, so I'm just going to group these again. And type in color the surfaces. Perfect. Now for the last step, let's rotate the split surfaces, those surfaces that we've created in the last part of this tutorial. Okay, so the first node we need is geometry.rotate. So just right click on the canvas, search for geometry.rotate. And what we need is origin axis degrees. Just drag that down here. And the first thing it's asking for is the geometry. And the geometry we are trying to rotate is the surface. So this is the list of surfaces we created previously. And the origin is the first point that we created at the beginning. So this point over here, if I show the preview, so that center point there, that's what I'm going to use as the origin. I'm just going to grab it and add it over here. Okay, and the axis is it wants to know the vector essentially to rotate around. So what we need is a vector.z-axis because I want the surface to be rotated along the z-axis. So vector.z-axis, that one. Okay, and you plug that in here. Now the last thing is the degrees. Okay, so we're going to use a range again. Double click with your left mouse button and type in 0 ... rotation to create a rotation variable ... hash divisions. Okay, so the divisions, let me just move this forward a bit. Okay, so the divisions essentially means the number of surfaces that we have, and we have a count here, so I'm just going to grab that and put it in, right? And the rotation has to be a new variable. So I'm just going to go back to the beginning over here and copy paste this, Ctrl C, Ctrl V, double click with my left mouse button and rename that as rotation. And because I wanted to rotate 360 degrees, right? And start from 0, then that is what I will set it as. And I can just drag this in here to group it and pull it out and move this into here. So now we will have a list of 19 numbers with a rotation from 0 to 97 because that's what our rotation was set as. Okay, so now all we have to do is plug this in here. And as you can see now, our surfaces are rotated. Okay, and so we need to take the geometry input for this guy, for this geometry color by geometry color now has to be the rotated surfaces. So I'm just going to move that in there, and then I'll hide this over here. And also there's something else I need to hide. Oh yeah, I also need to hide the NURBS curves we created. Just click on the group. I'm just going to hide everything in that group, and also this group I'll hide as well. Okay, so now it looks right. Okay, so I'm just going to group this again. Ctrl G, backspace, and say rotate split surfaces. Okay, so I don't, it's not a good idea to have your wires all tangled like this. So I try to move things around to like get them all cleaned up. Or in this case, maybe might be a good idea to copy this count, Control C, Control V, and actually plug that in there. Might look a little neater. And the other thing you can do, but I do not necessarily recommend it, if things are too messy, you can actually hide wires like that. For the inputs, I do this quite often, because sometimes I like to have them in the beginning, and when they stretch too far, it creates quite a mess. So as you can see, the graph does look cleaner now. Yeah, so just sort of try and arrange things in a way that doesn't create too much confusion when your wires overlap too much. All right, so that is the graph. That's what we've created in Dynamo. Now we're going to do the same thing in Grasshopper. But before we do so, let's flex the parameters to see that it works correctly. So over here, okay, as you can see, that works quite nicely. And the wave heights works as well, and the divisions. Oh no, we don't actually need to change that one. Cycles, the number of waves, sine waves created, and the radial divisions. Okay, pretty cool. Next, we'll create this in Grasshopper. And what you'll notice in Grasshopper, that Grasshopper handles geometry much faster. So it's going to be much more smooth in Grasshopper. See you at the next part of the tutorial. So let's go about creating the same thing on Grasshopper. All right, so the first thing we have to do, as we did previously, is add a point. So in Grasshopper, we need to use the construct point node. So I'm just going to double click with my left mouse button and to search for the node. So I'm going to type in construct point. Okay, so there's the node. Let's drag it over here. So if you hold Control and Alt, it will show you where the node is. So it's under vector. And as you can see over here, that's construct point. So Control Alt is a very nice feature in Grasshopper for that. And also I'm going to add a thing called bifocals, just for description. So it's a nice plugin for Grasshopper that adds descriptions to the top of nodes, just so it's easy to read. And yeah, so now we've added a point. Let me actually half my screen here so you can see what's happening. So immediately I've added the point node there. It creates a point at the 0, 0, 0. That is at the origin point of Rhino. Okay, so now I'm going to add 3 number sliders so I can control the values of the x coordinate, the y, and the z. Okay, so I'm just going to double click with my left mouse button again and look for number slider. Actually, we don't have to look for the number slider. We can just say let's say 100 and say enter, and that creates a number slider. And I'm just going to take that down to 0, drag it in there. Immediately it renames the number slider, which is fine. Control C, Control V, Control V. I like how it's renamed it to x coordinates, so I don't need to do any naming there. I'm just going to leave that, and does the same thing for the y and does the same thing for the z. Okay, that's great. Then I'm just going to group these together, Control G, and in you can actually give it a name here. The grouper name. So if you right click on the group, you type a name and you say inputs. So the bifocals will pick that up. inputs, yeah. But what I like to actually do is add a scribble. If you double click with your left mouse button, you search for scribble. So that actually allows me to add text. I like the text to be bold. So then I'm just going to type in here when I double click and say inputs. And then I select everything, then right click, and I actually right click on the group and then say add to group. Right. Perfect. So now we've added our point. So when we change the values here, okay, it is quite a small value. Okay, as you can see there, it changes, and the Y as well changes, and the Z changes. Okay, so yeah, maybe we should actually make it bigger. So I can just double click on this, and then the max value here, I can maybe add a 0 to it. Okay, so I'm just going to do the same for the others. 1000, okay, and 1000. Okay, so now we have a bigger slider. All right, that's fine. Okay, so the next thing we need to do to host those circles, we need to add a plane at that point. So I'm going to look again for a plane, double click with my left mouse button, and I'm going to say construct plane. Okay, there we go. And all the plane needs is that origin point. And if I zoom in there, you'll see now that there's a plane, that little square over there, you can see. Right. So it has all the inputs there. So for the x-axis of the plane, x-axis direction of the plane, and also the y-axis direction of the plane. So at the moment they are set correctly because I want my plane to be horizontal, so I'm not going to play with any of those other parameters. But if your plane has to face a different direction, you can change those values. All right. And so now the next thing we need is a circle node. So I'm going to search for circle over here, and then I want to use this one. There we go. Actually, that's the incorrect one. Sorry. Circle. There we go. Circle. This one has a plane and radius. Okay, circle by plane and radius. So now the plane is what we have here. So I'm just going to drag that in. And for the radii, remember in Dynamo we had a lot of circles. And so what we need to do here is a different way of creating it in Grasshopper. So we need to create a range of numbers, right? So, but the first thing we need is we need to construct a domain. So double click with my left mouse button again and look for construct domain. Okay. And for the A, I'm going to make that the inner radius, and the B would be the outer radius. Okay. So this is the workflow in Grasshopper. To set a range, to create a range, you need to make a domain. So the domain will be from the minimum number to the maximum number. So remember in Dynamo, we could type all that out in a code block. You know, when we said 0.100.hash20, right? So all of that was done in a code block. But in Grasshopper, if you need a range that is actually not from 0 to 1, you need to use this construct domain to actually create that domain. I hope that makes sense. Okay, so what we're going to do here is I'm going to create another number slider. I can actually just copy paste this, Ctrl C, Ctrl V. All right, and then I'll make the minimum value here. I'm just going to double click this and then say the minimum should be, let's say 50. So that will be the minimum radius we have. And the maximum for this, let's make it like 500. Okay. All right. So then I'm just going to right click on this and then rename it to inner radius. All right, then I'll copy and paste this again, Ctrl C, Ctrl V, double click, and then I'll call this one outer radius. Oh. Okay, and actually I need to change the range here, so we can make this one perhaps like 505, and the maximum value we can make, let's say 1000. All right, perfect. And then say okay, say great. All right, so now we have our inner radius and we have our outer radius. So now the domain we will be working, our circles that are being created working from is from 50 to 505. So the minimum radius, which is the inner radius, will be 50, and the outer one will be 505. Okay, then the next thing now to do to create our range of numbers, right? We need to look for a range node. Double click with your left mouse button, range. Okay, and now it's asking for the domain. So but you can see here by default the domain is from 0 to 1, but our domain that we've created is now from 50 to 505. So we feed that domain in here. Okay, and then the number, right, it wants to know the amount of circles essentially. So how many of these numbers do you want me to create? By default the number is 10. Okay, so what we're going to do here again is we'll look for an integer. Actually, we'll use a number slider as well. I can just double click number slider, integer. Trying to see if there's an integer slider on. No, there's none. Okay, so what we're going to do here is we're going to define the minimum. So let's say we want a minimum of 2 circles, and then the maximum we want is 50. Okay, so now we have a range of 2 to 50. Okay. Let me just see why this is in decimals. Okay, there we go. So I actually had to set that to an integer numbers, so that's where you change it. So floating numbers, where you have integer numbers, even numbers, or odd numbers. So that is also very important. And I'll say okay, and then I can just right click here and just rename it as radial divisions. Enter. Okay, so now we know we have a minimum of 2 and a maximum of 50 circles, and then we feed that number into number over there. So right, and then now we will have a list of 51 numbers, right? We want 50 numbers, right, as we asked for here, but what this range node gives us is 51 numbers. So there's a thing in Grasshopper where even if you've asked for 50, it's going to add 1 to it, right? It's kind of, I struggle to understand why, but what we can do here is come to this n, right click on it, right, and give it an expression and say x minus 1. So it's going to take our input number and subtract 1 from it. Okay, so now when we look here at the list, it's now given us 50 instead of 51 numbers. Okay, and then now what we can do is then feed these numbers into the circle, and then it will create our list of circles. So now we can play with it and make sure it works correctly. As you can see, that works. Okay, and our inner radius changes and also our outer radius. Okay, perfect. So now I'm just going to group these together. Add to group, and also group these together. Control G, and then I'll copy this text, Control C, Control V over here, and then right click, add to group, and then I'll just rename it, double click with my left mouse button, and then say create circles. All right, there we go. The next step, we will then create the sine wave curves like we did previously. Thanks. Hi there. So now let's go about creating the sine wave curves. All right. So the first thing we need to do, like we did previously, is to add points along the circumference of each of those circles. So those points will then be moved vertically at different heights to create the sine wave. All right. So the first node we need to do that in Grasshopper is called the divide curve. In Dynamo, it is called curve.point at parameter, if you remember. So search here, divide curve. Okay, and now it's asking for the curve, which are the circles, and by default the number of points that will be created, the count, will be 10. So now it's added 10 points to each of those circles, but we want to be able to change that value. Okay, so what I'm going to do is I'm just going to copy this, Control C, Control V, right? And then just right click and then change that over here to circumference. Okay, and then yeah, I can leave it the same amount of numbers there, and then add a thing called an integer container, connect it there, and copy and paste that again, Control C, Control V, and then I'll right click here and say wire display faint. So I learned this workflow from my friend Gerald. You should watch one of his the videos he presented on this channel on generative design, where he went through a Wallacey workflow. And please remember to like and subscribe. So then I'm just going to add this to the group. So I quite like this workflow because it helps keep the graph neat. So when you're trying to extend an input from the beginning of the graph all the way like somewhere very far, the wires are very thin and do not create a mess. Yeah, so I quite like that about it. And then you can connect this into number, right? And then we can change the values here, and as you can see, many more points are created on the circles. As you can see, Grasshopper is quite fast in the way it deals with these geometric operations. In Dynamo, it already start lagging. So this is very cool. So the next step now is to add a move node. Okay, so just double click with the left mouse button, move, there we go. And then what are we trying to move? The points. Okay, connect that into geometry, and then now it's asking for the motion, basically the distance to move the points upwards or downwards. Okay, but for that, if you remember, we need to create a range of values that move along a sine wave up and down to actually create that effect of the wave when we create the Nobs curve. All right, so to start with that, we need to add a range to the canvas. So double click and type in range. Okay, so now it's asking for the domain. Okay, so the domain here would be 0 to so let's say we wanted 20 sine waves, right? I'm going to copy and paste here, Control C, Control V. Just right click here and call this cycles. Okay, just going to shorten that. Okay, and then I can actually double click on that and just change this, let's say, to 20, so we don't have more than 20 waves. You can leave that as 50 if you want yours to be more. Okay, so then we have here, let me just change this to 10. Okay, so I can make the domain, as you can see, by default the domain is 0 to 1, but if I feed a value, one value in here, okay, it's going to change the domain to 0 to 10. You can also create a domain as usual. Domain, construct domain, that one. All right, the default is 0, and if you connect this value in here, it's going to change the domain to 0 to 10, and if I plug it in here as well, the domain will now be 0 to 10. Okay, so much more efficient to just connect the value, you know, from there straight, but that also works. So I'll just leave it. So Control C, Control V. I'm going to make my graph neat again like I did previously. Control C, Control V, connect that in there. I make the wires display faint, and then I'll connect that into B over there. Okay, so now we have, that domain from 0 to 10. So now we need to add numbers. So the steps would be 50. I'm sorry, not 50. It would replicate the number of points along each of the circles. Okay, so what I'll do here is just copy paste this, Control C, Control V, bring that down. So move this up so there's not tangling of wires too much, and then I'll feed this into number. But remember the issue with the range node. So what we wanted was what? 25, but it's giving us what? 26. So we need here to right click and set an expression and then say x minus 1, and then commit the changes, and then now we have 25. Okay, so in Grasshopper we do not need to work out the math we did in Dynamo, where we actually did some, we said math.sine, and then we worked out the whole 0.360 times cycles formula. You can just scroll to the beginning of the video to check that out again. We don't need to do that here. So all we need to do is feed these values, right, into something called a graph mapper. So just double click with your left mouse button and search for graph mapper. Okay, as you see, by default there's no graph shown. I'm going to feed the values in here, but now the graph, you right click on the graph there, and then you search for graph types, and then what we want is what? A sine wave. Okay, and then you just go over here and drag it to the center. Okay, so now it's going to output a list of values. If I go to the parameters tab and then put a panel, you can now see it's created a set of 25 numbers, as you can see, going from 0, then coming down again, then going up again to create the, you know, to create the range of numbers for the sine wave. All right, but as we did previously, we still have to remap these values to real world numbers, because obviously the 0.934, 0.22 numbers are not going to move these points to the right height to create actually be able to see the effect of the wave. So we need to remap them. Okay, so I'm going to create two new inputs at the beginning here, and then I'm just going to, let's say, copy paste this, C, Control V, and then just call this wave height 1. Okay, I think just change the range here double click, and then I'll say make that 100. Okay, and then copy paste, Control C, Control V, and right click and say wave height 2. Okay, so I think I will change this one. Let's make sure they are different. And then what the next thing we need is a node called remap. Just double click with your left mouse button and look for remap numbers. Okay, and then it's asking here for the values to be remapped. Okay, and over here it's the source, right? So it's asking what is the range of the source numbers, right? So our source numbers are pretty much 0 to 1, right? So we're going to leave that empty. By default it is 0 to 1, and then now it wants the target domain, right? So our target is from, at the moment, 15 to 67. So we need to feed those numbers in. So I'm going to look for a number container. So if you click here under this params tab and number, and just click here, it's going to connect that in here. Control C, Control V. It's actually fine if it's an integer as well. It actually doesn't matter. Plug that in there and copy these twice again. Control C, Control V. Connect there and connect there. Right click on both. Wire display, faint. Right click again, wire display, faint. Okay, then I'm going to move these two down here. Okay, and then I'll create construct a domain using these numbers. So domain, look for domain, and it's this one. Where is it? Construct domain, and then plug that in there, and then plug that in there. Okay, so now we have a domain from 15 to 67, and then we plug that over there. So now when we get out a panel and we look at the values that we've created, as you can see now they've been mapped along our range. Okay, so they're no longer small numbers like before. See, now they've been remapped to 1563.57 as required to create the sine wave. Okay, so now the next step is to create a vector. Okay, so from in Dynamo we can just directly, we can take these values, right, and connect them into a geometry.translate node to move the points upwards, to move the point vertically. But as you can see here, in Dynamo you have a geometry, and then you have a movement distance, and you also have a vector. So but in Grasshopper you have to convert these values essentially to the vector before connecting it in here to this motion vector input, right? So then I'm going to look for a unit Z, okay, because I want to move the points vertically, and I'll connect these numbers that have been remapped in there, and then connect that vector into this over here. Okay, but it hasn't moved correctly. No, I think it has, but let's just create the waves first. So just to confirm, then I'm going to look for an interpolate, right? Interpolate, there we go. Interpolate, let's say that curve over there, and then connect the geometry into vertices, and as you can see they were actually created correctly. All right, okay, so now that is the Grasshopper workflow to create the sine waves. I'm sure there are many other ways of doing this, but this is just how I've managed to replicate using my Dynamo sensibilities almost, and just trying to replicate what I've done previously. So then I'm just going to say Control G to group this together, and copy the text here, Control C, Control V, and then I'll say create sine wave curves, and I'll say OK, and I'll just group these together, add to group. All right, then I'll group these here as well, add to group, and then we can play with the parameters just to see that everything is working correctly. So you can see that is working, and number of cycles, that's also working. Right, everything is working. Okay, in the next step we will create the split surfaces, right? And then we're almost done. Thank you. Hi, so now let's go about creating surfaces between each of these curves. So from there to there, from there to there, and from there to there. But let's actually clean up the graph so you can actually see more clearly. Right, so I'm just going to right click here and then remove the preview, right click here to remove those points, and also the base circles. Okay, but as you can see, we missed something here. So we need to go over to this node and change this value here, the periodic, which controls if the curve is closed or not. And we set that to true, so now it closes off. And also, if you're not satisfied with the wave that's actually created, you can play with the graph. So the graph mapper allows you to tweak these things around, so you can, it gives you quite a lot of flexibility in looking for the form, like a particular shape you're trying to go for. If you right click on the graph mapper, you can also choose another graph type. So there's a parabola, which actually does not look particularly good. And sorry, if I search here for, there's also that kind of sine wave. It's interesting. Okay, and we can look here as well. So there's quite a lot to play with there, but let's not waste too much time and go back to our sine there. Okay, I'll just leave it like this and then continue with the graph. Okay, so to create the split surfaces between each of the waves, right, as we did previously, what we had to do was duplicate this list here of interpolated curves, of these NURBS curves. Okay, so what we have to do first is look for the duplicate data node. So duplicate data. Okay, so then what data are we trying to duplicate, right? Obviously the waves. Okay, so we're going to get those curves there and plug them in to there. So now if we get a panel from the parameters tab, okay, and we plug those, and we plug the data into the panel, as you can see here, it's duplicated each item on the list twice, right? Each item twice. Okay, so what we have to do before we continue is to right click here and flatten. So in Dynamo we will have to get a different node which is called a list.flatten to do that, but in Grasshopper the nodes have that built in, right? So if you right click here, you can search for flatten, but I think you can still flatten with a node in Grasshopper if you wanted, right? There's a flatten tree, but I think we'll do the same thing. So let's actually just so if I just remove that and then plug that in and plug that, you see it does the same thing. But you know, just use the node, it's built-in qualities. Once you see that icon over there, you know that something has been done to the node, so it's easy to also go back and change it if you wanted. Okay, So the next thing we need to do is get a list length node. Okay, and plug that in here. So now we know the list length is 50. Then we look for a series node, series. All right, I'm going to explain what all this means. So we're going to use this series node here, as you can see in the description, create a series of numbers. So what we're going to do is use these numbers, right, to remove the item at the first index, the index of 0, and the item at the last index, which is the index of 49. Okay, so I'm going to start the series from set number. I'm going to start it from 1. Okay, as you can see, and I'm going to set the count to this list length. Okay, but remember, I only want numbers from 1 to 48, so I can only get the second item. Okay, that from 1 to the second to the last item. Okay, which is at 48. Okay, so in Dynamo, you remember we had to use a list.remove item and index for this. Okay, so this was the method I found to do this on Grasshopper. I'm sure there might be other ways, but as a new Grasshopper user, this is what I came up with. So then I'm going to right click over here and then set the expression to x minus 2. Okay, so as you can see, now it's made a series of numbers from 1 to 48. So I can just plug that in here so you can see. So from 1, okay, to 48. Okay, now what we need to do is get a node called list item. Okay, now plug our list, which is our list of NURBS curves. Plug it in there. The index would be this series of numbers. Okay, and now when we plug that into the panel, you can see that it's only gotten 48 of the items. Okay, so that is from 0 to 47 as we intended. So now we've removed the first. Remember, so because we duplicate the data, there will be 2 NURBS curves sitting there. We removed the first one, and now there's only one here. There's 2 here, there's 2 here, there's 2 here, and also at the last position, we've removed the duplicate NURBS curve, and we only have 1 here now. So now when we create the surfaces between each of them, it will be created from there to there, and because there are 2 NURBS curves sitting over here, from there to there, and so on. All right, so that's why we had to remove the NURBS curve over there, the overlapping one, and the other one. All right, so now the next thing we need to do is use a node called partition list, which is list.chop in Dynamo. Okay, so what partition list is going to help us do is break up the list here, which is currently flat, into sublists containing 2 items. Okay, so let's take a look and see. If we look here, the size is asking for, let's actually see what it comes up with first. Okay, so the size, if I right click here, I'll set the integer to 2. So I think by default, if I look here, it's set multiple integers, so 3, 2. All right, but I just want it to be 2. So I'm just going to set one value, and as you can see, it's made sublists of 2 NURBS curves, right, in each of those sublists. All right, perfect. So now what we have to do is loft. So get the loft node and plug it in there, and now we have our nerve curves between, our surfaces between each of those nerve curves, right? From there to there, and from there to there. Okay, but you can't see it now, obviously, because we haven't created a rotation yet. So what I'm going to do is just select all of these, Control G, and then I'll copy this text again, Control C, Control V, and then say here, create split surfaces. Okay, and just right click, add to group. All right, so next we will color the surfaces so we can actually see if they actually have been split or not. But if you look in the list, right, you can actually see that there are surfaces over there, right? But let's flatten the list actually. So flatten, because they don't actually have to be in sublist. So we put all of them in one list. As you can see now, we have 24 surfaces. Perfect. All right, so another thing is there's this package called Meta Hopper. It just shows you the nodes on your graph, how long they're taking. So when they take long, it actually gives you an indication. So this is the first node that's taking quite a while to work. Generally, when you're doing a lot of heavy geometrical operations, that's when these things happen. But it also shows you on your entire graph how long each node is taking to run, which is quite helpful when you're trying to debug and make your scripts work faster. So anyone who doesn't know, you can just go look it up, Meta Hopper, and yeah, that's also very handy. All right, so now let's go on to the coloring of the surfaces. The next thing to do is color the surfaces like we did previously. All right, so we need a list length node, list length. Okay, and plug the loft into the list length. So it shows us here that we have 24 surfaces. Okay, and then from that, create a range. Okay, range, and plug that into N. So as you remember, the domain here is always by default set 0 to 1, right? But we want, so now we want a list of 24 numbers from 0 to 1. So I'm just going to plug this into the panel so you can see. Okay, so it goes from high, from low, 0, to the highest, which is 1. So, all right, so we're going to use these numbers very similarly to how we use numbers from 0 to 1 in Dynamo to pick colors along the color range, right? In Dynamo, it's called a gradient, and it's located in the params tab, just right there. Okay, I'm just going to click on it and then drop it. Okay, so but before we do this, before we feed these numbers into here, we need to randomize them, right? Because we want the colors on the surfaces to be different from each other. If we do not randomize them, it's just going to create a gradient of color, and that will be hard to tell them apart. So I want to be able to randomize these and pick random colors along the range, along the color range of the gradient. So I'm going to look for a jitter node. Okay, and then you plug the range of numbers into the jitter, and then you see here the numbers are randomized, but we'll put in the panel shortly. So over here on the jitter, the jitter strength is always 1, and if you say 0, it's going to be no shuffling. So there's basically a range of shuffling. You can pick the intensity of the shuffling using J, and the seed basically gives you a different shuffle when you change the number there, but the seed by default is 2. So I'm just going to take it as is. Okay, so as you can see here, the numbers are shuffled. They're not going in an orderly fashion from 0 to 1 as they were previously. And then I'm just going to plug these values in here. Okay. So as you can see here, the lower limit is 0 and the upper limit L1 is 1. So this range, this gradient here is going to give us, it's going to be start from 0 here to 1. So if we put red here, it's going to be at 0, and blue, if we put blue there, it's going to be at 1. Okay, so that's what that sets. It sets the range, the lower limit to 0 and upper limit to 1. You can change that if you had to. So I'm just going to add another point here by clicking on this round, this quadrant here that looks like a rainbow. Click on it, and I'm just going to drag this one to 50 to center it, and this one to the end at 100%. I'm just going to double click on one of them, and then I'm going to change the color here. Let's say I want it to be blue. Let's pick a soft blue. Oh, that's a purple. Okay, and then I can make that green. Okay, so just click on the dot, make it green. Okay, and I'll make it green again. Okay, and then this one, I guess we can leave it as red. Okay, so that's all right. And then when you say okay, it shows you that the range has been applied. And over here, if I connect this into the panel, we already have color values here from 0 up to 24. So we have 25 colors. Okay, so one thing we forgot to do is, because we actually do only have 24 surfaces, we need to subtract here using an expression. We need to say x minus 1. Okay, so we only get 24 colors. Sorry, seems to be a mistake here. Oh, I see why that didn't work. The expression had to be typed there at the number. Okay, and I think I did that at the output. Sorry about that. So as you can see, that's actually working now. So that was my error. So now we have 24 colors. Okay, so now we're going to look for a preview node. Custom preview. Okay, now plug the colors in here to material. So color would be material, and then grab the surfaces and plug them in here. Okay, so now I'm just going to hide this preview. Okay, as you can see here, our color swatch does not have the last color. So I'm just going to click here again, maybe make this a red. We seem to have undid that somehow. And then we can make this a blue. Okay, and just so you know, you can actually save your swatch colors if you don't want to have to save them over and over. So you can set as default, and these are the list of swatches already loaded. Okay, quite intense colors. But then I'm just going to group this together, Control G, and copy and paste that, and just say color the surfaces. Okay, select all of them and then say I add to group. Okay, and then we can play with our surface. Okay, radial divisions. As you can see, that is working quite well. Thanks. So the last thing now is the final step, and we will put at the end over there, which is to rotate these surfaces to create that twisting effect. Hi there. So the next thing to do is rotate the surfaces, so the surfaces in this list. Okay, so to do that, we need to get a rotate node. So double click with your left mouse button and type in rotate. There we go. So it's asking for 3 inputs. So geometry, angle, and plane. Okay, so the geometry we have right over here, so the surfaces. The angle, we need to add a new parameter. And then look here, I can just copy this, Control C, Control V, and then double click, and then set the maximum as 360 and the minimum as 0, because I want a rotation maximum of 360. Okay, set OK, and then right click over there, change the value here to rotation. Great, I'm just going to group that together and then copy this integer value here and just add it, Control C, Control V again, grab that, add this to the group, and then change the wire display to faint, and then I can just grab this over here and put it in angle. Okay, and then right click and then change that here to degrees, because by default I think the degrees is in radians also, but here I want it to be in degrees. Okay, so but as you can see, all the surfaces, right, are still rotating together. We want to create that twist effect, and that's not what we're seeing at the moment, so we need to create that. Okay, so I'm going to hide this preview here so we can see what we're creating clearly, and I'm going to hide the interpolated curves preview and that preview as well. And it seems we still need to move that preview. Okay, right, so now we need to construct a domain. Okay, so we're going to say domain, and also construct domain. There we go. Okay, and then add that to here. Okay, okay, and then add a range. So we're going to look for range. Okay, then plug the domain, which at the moment is up to 58, in there, and then use the list item. I can just copy this and plug that in here. See, the list has 20, and here we have 21, obviously, because the range always adds 1, as we noted previously. So x minus 1, and now we have 20 items. Okay, so that is the rotation values. So from all the way from, let's plug in a panel. So you can see, so these are rotation values from 0 to 3, 6.1, 9.1, all the way to 58 for, and so that is for 20 surfaces, because we have 20 surfaces in total over here. Okay, so now what we have to do is plug that rotation value into here. Oh, sorry, wrong, incorrect. I'm just going to right click here and disconnect. Okay, plug the angle into there. Okay, as you can see, it's rotating, but it also wants a plane. So, but you can just leave it as the world XY, or you can actually also grab your center point there. I can actually just look for point and then move that in there. Right click and make the wire display to faint. Okay, again, grab that point. The point automatically gets converted to a plane. Okay, and so now we have it there. Okay, and then what I'm going to do here is just group these together. And then just say rotate surfaces. Okay, then I'm going to group this here, add to group. Great, so that's the final step. So all we have to do now is just take this final geometry and plug it into this color preview. Okay, I'm going to show the preview. Just right click. There we go. And then remove these over here. Remove that preview. Okay, so as you can see there, we've got the final effect with the twist. Okay, we do the rotation. And oh, I think it's something I missed. No, that's actually it. It's working correctly. Okay, you can see there rotation and also the wave heights, the number of waves, the radial divisions to make it finer, and also you can play with the graph mapper. Yeah, thanks for watching the video. If you liked our video, please like and subscribe. And also you can tell us at the bottom of the video what tutorials you'd like us to work on, so we can have a so we can plan for the future. Yeah, just hit the link below and fill the form, and please leave some comments if there's something unclear, or if you want us to just point something out. Yeah, just thank you and have a good one. Cheers.